video, we're going to be looking at scenarios. We're going to take the information from a scenario, write an equation, and then we're going to solve that equation. And so let's look at the first scenario. Maddie has $8 more than Mrs. Hong. If Mrs. Hong has 17, how much does Maddie have? The first bit of information is who has more money. Maddie has more money. She has $8 more than Mrs. Hong. We don't know how much Maddie has, though. So in this unknown, this is where we put our variable. Remember, a variable is something that represents a quantity or something that we don't know yet. And so we don't know how much Maddie has. So we're going to say M is the money that Maddie has. For our equation, we're thinking about how these things are connected. So Maddie has $8 more than Mrs. Hong. Mrs. Hong has 17. So if we had 17, if we start with Mrs. Hong, and we add 8 more, because Maddie has 8 more, then we're going to get the amount of money that Maddie actually has. And so when we look at this equation, 17 plus 8, we're just going to simplify that to 25. Now when I look at the solution check, I could substitute this value back into my equation and make sure it works. It should. It's a solution. If you remember that term, it makes it true. The last thing I do, though, is I check to make sure in the context that this makes sense. So Maddie has $8 more. She has 25. Mrs. Hong has 17. It fits. Maddie has more. The next one, Sam has gone to the gym twice as many times as Kyle. Sam's gone 10 times this week. How many times has Kyle gone? We don't know how many times Kyle's gone. So let's use that as one of our variables. I'm going to call it K. K is number of times for Kyle. Sam has gone twice as many times as Kyle. So if we know how many times Kyle's gone, then we can multiply that by 2. So Kyle went a K number of times. If we do K times 2, we're going to get Sam's. Or if we just say Kyle times 2 is going to equal Sam's. So now K was for Kyle. That was our variable. And then it says Sam went 10 times. So solving this out, thinking about what value we could substitute in for K here, K would be 5. The last thing I do is I think about this solution check. If I substituted 5 back in, would it make it true? 5 times 2 is 10. It does work. And then I also think about, in terms of the scenario, Sam's gone twice as many. So if Sam went 10 times, Kyle went 5, that makes sense. All right, the last one. Earl is 5 years younger than his older brother. His older brother is 18. His older brother is older. How old is Earl? We don't know how old Earl is. I'm going to call that E. Age of Earl. We do know that he's 5 years younger. If we have his brothers, and we subtract 5, we're going to get Earl's age. Now think about what each of these represent. His brother is 18. His brother is 18. Take away the 5, we get Earl's, which was E, which is what we're looking for. And so simplifying this down, we get 13 years old for Earl. We would call that our solution. When we substitute it back in, it makes it true in this case. The last thing to emphasize is just make sure we have labels on these. Labels are really, really important in these scenarios. At this point, I want you to press pause. I want you to try the other 2 problems, and then hit resume when you're finished with those problems. All right, thanks for completing those problems. Just want to share out really quick the solutions to those so you can check and get some feedback on your problems that you tried. Notice how I defined variables. Notice how I wrote out the equations and how I solved those out. So this should give you a little bit of information. Again, we can use any variable, any letter, X, Y, or 2 that I chose here, for the unknowns, things we don't know yet, and things we're also perhaps trying to find. Thanks for joining me in this lesson. We will do more with equations in the future.